Welcome to the slop farm. Enjoy the video.
You start by opening a new design and selecting the component library. Choose TTL or CMOS depending on your target. Once done, set grid snap and place VCC and G&D rails so nets behave predictably. Make sure to add input pins and a simple gate immediately. This gives you a concrete test case. Then wire the parts, label nets for clarity, and save the project. This quick, focused setup prevents later confusion and gets you running the first simulation within minutes. Now you assemble the core logic. Add gates, flip-flops, and any multiplexers the design requires, orienting and labeling them as you go. Once placed, configure each part's properties like propagation delay and active polarity so timing will match real behavior. Attach probes or indicator LEDs to critical nets and insert a clock source. Set its frequency and duty cycle to reflect expected operation. As you connect elements, run brief test, pulses to confirm outputs, run the simulation in transient or steady-state mode, and inspect waveforms and signal states. Zoom into timing edges and verify setup/hold margins. Once verified, iterate. Adjust delays, add decoupling or buffers, and refactor confusing logic into modules for readability. Export the netlist or an image for documentation and save version copies. If things go wrong, probe suspected nets first to isolate where signals diverge. This targeted check is faster than redoing the entire circuit and usually pinpoints.
Thanks for watching. Consider subscribing if we helped you today.